Hello friends, myself Dr. Nandakumar Raubole from College of Engineering Ambazogai is going to deal with numerical methods in mechanical engineering. This is our 17th lecture. In previous lecture, we have discussed about multiple application of trapezoidal rule and Simpson's 1/3 rule. So today we are going to discuss about multiple application of Simpson's 1/3 rule and Simpson's 3/8 rule. Now let us see this multiple application of Simpson's 1/3 rule. So in case of a Simpson's 1/3 rule, so we are going to consider 3 points, that means 2 segments. So we are going to consider 3 points at 2 segments, but here now multiple applications, we are going to consider multiple segments of a polynomial, and to find out integral of that polynomial, we can divide that range into multiple segments. So multiple application of Simpson's 1/3 rule. Let us consider this diagram. So here this is f of x a along y-axis, along x-axis the independent variable x, and this is the function which we can plot here. So this is to be integrated to find out area below this curve. So in order to find out area between a to b, we integrate this function f of x in the limits of integration a to b. But in case of simple Simpson's 1/3 rule, we divide this complete segment into 2 segments or 3 points. So but in case of multiple application of Simpson's 1/3 rule, so this is divided into n number of segments, small segments, and area of each segment is obtained. So here like this is divided into multiple segments. So first 2 segments form one Simpson's 1/3 rule, then this forms second Simpson's 1/3 rule, then this forms another Simpson's 1/3 rule, and this forms again another Simpson's 1/3 rule. So by doing so, we are going to find out the area below complete this function f of x. So now let us consider step size h is equal to b minus a. So this is the total range b minus a, and that we want to divide into n number of segments, that is divided by n. So total integral can be represented as integral I is equal to integration from x0 to x2, then integration of function f of x dx, and again second segment, that is integral from x2 to x4, that is x2, x3, x4, 3 points or 2 segments. 3 points or 2 segment means, say for example, this is the distance, this is divided into 2 parts, so this is known as 2 segments, but we are going to consider 3 points, 1, 2, 3. So this is x0, x1, x2. If this is x2, then x3, x4. So again this is f of x dx plus so on plus integration xn minus 2 xn f of x dx. So now this can be written by using Simpson's 1/3 rule like this, which is equal to h by 3, and then f of x0 plus of 4 times f of x1 plus of f of x2. For first set we can write like this. Then for second set also we can write h by 3. F of x2 is first part plus of 4 times f of x3 plus f of x4. Again close this bracket and plus dash 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 plus h by 3 f of x n minus 2 plus 4 f of x n minus 1 plus f of x n. So now from this we can take h by 3 as a common, or in place of h by 3 we can take b minus a divided by n. So here h by 3 is taken common, and from these brackets we can write here as f of x naught once plus 4 times summation of I is equal to 1, 3, 5 odd numbers up to I is equal to n minus 1 f of xi. And here you can see 4 times f of x1. So here f of x3 is 4 times. So on 4 times f of xn minus 1. Then plus 2 times. We can see here f of x2 is in this bracket as well as in this bracket. So this is 2 times. So 2 times summation of I is equal to 2, 4, 6 like this. So here 2 is repeating, 4 will repeat, 6 will repeat in, and so on. So this is up to x n minus 1, n minus 2, and this is f of xi plus of f of xn. So lastly f of xn is once, only once, and f of x naught is once, but all these odd terms 1, 3, 5 are 4 times, and even terms are 2 times. So this is, or else we can rewrite this as in place of h we can write b minus a divided by n, b minus a divided by 3n in bracket. We can write this as f of x naught plus 4 times summation of I is equal to 1, 3, 5 dash dash and so on up to n minus 1 f of xi plus of 2 times summation of I is equal to 2, 4, 6, and that is up to n minus 2 f of xi plus of f of xn. So this is the equation for integral using multiple application of Simpson's 1/3 rule. So now this helps us to find out the approximation for the area or integral of this function f of x. So here also there exists a error. So approximate error EA is given by minus b minus a to the power of 5 divided by 180 n to the power of 4 and f bar of fourth zeta. So fourth derivative of this function, when integrated, we get this function. So this gives us approximate error of Simpson's 1/3 rule multiple application. Now proceeding with a numerical, we can have the real idea about this multiple application of Simpson's 1/3 rule. Let us consider f of x function, which is equal to 0.2 plus of 25x minus of 200 x square plus of 675x to the power of 3 minus 900 x to the power of 4 plus 400 x to the power of 5 between the limits of integration a is equal to 0 to b is equal to 0.8, and take 4 segments, that is n is equal to 4 with step size h is equal to 0.2. Sometimes this number of segments and step size may be given or may not be given. So if it is not given, then we have to assume number of segments and step size. So now for x naught is equal to 0, f of x naught, if we substitute x is equal to 0 in this above equation, this becomes 0.2. Now we are going to divide this range 0 to 8 into 4 segments. So 0.8 divided by 4, so step size is 0.2. So step size is 0.2, therefore x1 is equal to 0.2 first step. So f of x1, if we substitute 0.2 in this function f of x, then we get this as 1.288. Then x2 is equal to 0.2.4 f of x2. So if we substitute 0.4 in this equation, given equation, then we get this as 0.2.456. Then x3 is equal to plus 0.2 means 0.6. f of x3 we get as 3.464. Then x4 is equal to 0.8. Therefore f of x4 becomes 0.232. 0.232. So here we have divided it into 4 segments. So between these two, first segment, between these two we get second segment, between these two we get third segment, and between these two we get fourth segment. So these are 4 segments and 5 points. 1, 2, 3, 4 and 5. So we can see 0, 1, 2, 3, 4, 4 points. So 4 segments and 5 points. So now writing this equation for Simpson's 1/3 rule, multiple application of Simpson's 1/3 rule, just what we have written. This equation, I is equal to b minus a divided by 3n in bracket f of x naught plus 4 times summation of I is equal to 1, 3, 5 odd numbers up to n minus 1 f of xi plus of 2 times summation of I is equal to 2, 4, 6 n minus 2 f of xi plus of f of xn, close this bracket. So x naught is there, xn means last term is x4, x naught xn means x4, and odd terms are 1 3, even terms are only 1, that is x2 is only even terms. So this equation is modified according to our requirement, that is b minus a divided by 3n in bracket f of x naught plus 4 times, so 135 f of x1 f of x3, 5 is not there, so here 4 times f of x1 plus of f of x3 plus 2 times even numbers is only one, that is x2, so f of x2 plus f of last term is f of x4, so n is equal to 4, close this bracket. Now we know everything, that is we know x0, we know x1, we know x3, f of x3 we know, f of x2, and we know f of x4. So b is nothing but 0.8, a is 0 divided by 3 into n value is 4, we have divided it into 4 segments, divided by 4, then f of x0 is 0.2 plus 4 into f of x1 is 1.288 plus f of x3 is 3.464 plus 2 into f of x2, f of x2 is 2.456 plus of f of x4 is 2.32, sorry 0.232, close this bracket. So on simplification we get this as 1.6234 so this integral we obtained. So true integral which is given in this problem is true value, or true integral of this is 1.6405334. Therefore the true error is equal to, true value is 1.6405334 minus 1.6234667 whole divided by true value is 1.6405334 into 100. So this works out to be true error, relative true error is 1.04%. So earlier in case of Simpson's 1/3 rule or normal Simpson's 1/3 rule, we obtained 16% as this error as 16%. Now by using multiple applications of Simpson's 1/3 rule, true error has been reduced to 1.04. Now if we want to find out approximate error, by Simpson's 1/3 rule multiple application, which is given by formula minus b minus a to the power of 5 divided by 180 n to the power of 4 f bar of 4th order zeta. So minus b minus a, b is 0.8 minus 0 to the power of 5 whole divided by 180 into n to the power of 4. N value is 4. So here we have divided it into 4 segments. So n value is 4. 4 to the power of 4 into this f bar fourth order of zeta is minus 2400, which we have calculated in previous problem. So minus 2400. So this error is going to become 0.0170. So in previous case, same problem was solved by using simple 1/3 Simpson's rule, and there we found that the error was approximate error was 0.273. So this was 0.2730. So this error is reduced by the use of application of multiple Simpsons 1/3 rule. So this error also has reduced. This error earlier was 16%. So this was 16%. This is reduced to 1%. So if we divide the complete area into multiple segments, and if we use this application of Simpson's 1/3 rule, the error is likely to reduce to the greater extent. So coming to Simpson's 3/8 rule. A third order Lagrangian polynomial can be fit to 4 points and be integrated. So in case of Simpson's 1/3 rule, we have divided this complete segment into 2 segments or 3 points. But in case of Simpson's 3/8 rule, a third order Lagrange polynomial can be fit to 4 points and integrated. The integral I is equal to integration a to b function f of x dx, and this can be yield to approximate integral 3h divided by 8 f of x naught plus 3 times f of x1 plus 3 times f of x2 plus of f of x3, where h is equal to b minus a divided by 3. So on substitution of this h is equal to b minus a divided by 3, integral I becomes I is equal to 3 gets cancelled, h by 8, h means b minus a divided by 3. So b minus a divided by 3, this 3 gets cancelled with the 3 numerator, and in denominator we are going to have only 8. So this is into f of x naught plus of 3 times f of x1 plus of 3 times f of x2 plus f of x3. So this is the Simpson's 3/8 rule. So in this case, truncation error is given by for Simpson's 3/8 rule, which is given by minus 3 divided by 80 h to the power of 5 f bar of fourth zeta, or else this h can be substituted by b minus a. Therefore this true error becomes minus b minus a to the power of 5 divided by 6480 f bar of fourth order zeta. So this gives us truncation error when we use Simpson's 3/8 rule for simplification of a problem. So now we'll have a simplification of the same problem. So let us consider the problem, same problem as usual which we have solved. F of x is equal to 0.2 plus 25 x minus 200x square plus 675 x to the power of 3 minus 900x to the power of 4 plus 400 x to the power of 5. A is equal to 0 2, b is equal to 0.8, and let us consider n is equal to 4 segments with h step size of 0.2. So now again, when we want to use Simpson's 1/3 rule, so first we will write this equation for Simpson's 3/8 rule, that is b minus a divided by 3n, just now which we have obtained. Sorry, this is Simpson's 3/8 rule, so this is wrong. So this is Simpson's 3/8 rule gives us like this, that is b minus a divided by 8 in bracket f of x naught plus f of 3f of x1 plus 3 times f of x2 plus f of x3. So therefore what we have to do is, here x naught is equal to 0. If we substitute 0, then f of x naught, which is going to be 0.2. So if we substitute 0 in this first equation, f of x is going to be 0.2. So x1, now x1 is 0.2. if we take 3 segments or 4 points, 3 segments or 4 points, so 0.2, if we divide it by 0.8 by 4, 0.2, each division is of 0.2, so 0.2 f of x1, which is going to be 1.4327. So if we substitute 0.2 in this equation, we get 1.4327, 24287. Then x2 is equal to 0.4. if we substitute f of x2, which is going to be 3.487176, 48717696. Then x3 is equal to 0.6 if we take. So here Something is going to be wrong, I think. 4 points. 4 points means 3 segments. 3 segments is wrong. See here. 1, 2, 3 segments up to x3. So we want to divide it into 3 segments. 3 segments, 0.8 divided by 3. 0.8 divided by 3 we have to take. 3 segments and 4 points. We are taking only 4 points. 1, 2, 1, 2, 3, 4. 4 points means 3 segments. So this has to be divided into 3 divisions. So if we divide it into 3 parts, 0.8 divided by 3. 0.2666. 0.26660. 0.266 into 2, that is 0.533, and 0.8. So in this way we have to divide this range 0 to 0.8 into 3 segments. This is first segment, second segment, third segment, and 4 points. So f of x3 we get. So here if we substitute 0, then f of x0 is 0.2. If we substitute 0.26666, this works out to be 1.432724. If we substitute 0.533 in this equation, then we get this as 3.48717696, and if we substitute 0.8, then it is 0.232. So substituting all these values in this first equation for Simpson's 3/8 rule. So I is equal to b minus a. B is 0.8, a is 0, divided by 8 into f of x0 is 0.2 plus 3 times f of x1. F of x1 is 1.43272428 plus 3 times f of x2. 3 times f of x2. F of x2 is 3.48. 3.48 717696 plus 0.232. On simplification, this integral we get as 1.51917037. So this is the integral which is given or obtained by Simpson's 3/8 rule. So now the true integral value which is given is true integral I. This is true, which is given as 1.6405334. So true error can be obtained by 1.6405334 minus the approximate integral which we have obtained is 1.51917037 divided by true integral is 1.6405334 into 100, and this works out to be 1 point, sorry, this works out to be 7.4%. Error works out to be 7.4%, and truncation error which is given by this Simpson's 3/8 rule, that is truncation error is minus b minus a to the power of 5 divided by 6480 into f dash of fourth zeta. So now b minus a minus 0.8 minus 0 to the power of 5 divided by 6480 into minus 2400. So this works out. So this is minus 2400. We have calculated it in previous lecture itself. So this truncation error is going to be 0.12136. So this error is also reduced. So now same problem, if we simplify using 5 segments or 6 points, then we have to use Simpson's 1/3 rule as well as 3/8 rule. Combination of Simpson's 1/3 rule and 3/8 rule is required if we want to solve this problem using 5 segments or 6 points. So now let us consider here 5 segments or 6 points. One, 2, 3, 4, 5. So we have, say, first segment, second segment, third segment, fourth segment, and fifth segment, and there will be 6 points. So 1, 2, 3, 4, 5, 6, 6 points. Same problem which we are going to solve since starting. Same problem we will be solving, that is f of x is equal to 0.2 plus of 25x minus 200x square plus 675x to the power of 3 minus 900 x to the power of 4 plus 400 x to the power of 5. So integrate this between range a is equal to 0 to b is equal to 0.8 using Simpson's rule with 5 segments. So when we have 5 segments, so at that time what we do, first 2 segments are solved by using Simpson's 1/3 rule, and next 3 segments are solved using Simpson's 3/8 rule, and the resultant is added. So total distance, so for example this is a polynomial, so this is divided into total 5 segments, 1, 2, 3, 1, 2, 3, 4 and 5 segments. So there are 5 segments, 1, 2, 3, 4 and 5. So out of 5 segments, first 2 segments are used to simplify using Simpson's 1/3 rule, and last 3 segments are solved using Simpson's 3/8 rule. So now here let us divide it into 5 segments. So when we divide h value of 0.8 into 5 segments, then it works out to be 0.16. So each segment will be of width 0.16. So therefore f of x naught is equal to 0 if we take, then f of x naught is going to be 0.2. Then x1 is equal to, if we take 0.16, so step size is 0.16, then f of x1 will be 1.29691904. Then x2 is equal to 0.32 if we take, then f of x2 is equal to 1.74339328. If we substitute 0.32 in this first equation, given equation, then we get f of x function value. Then x3 is equal to 0.48. Then f of x3 is 3.18601472. Then x4 is equal to 0.64. f of x4, if we substitute 0.64 in this equation, then this works out to be 3.18192896 and x5 is equal to 0.8. Then f of x5, if we substitute, then it will be 0.232. So now we have to use first, for first 3 points, 1/3 Simpson's rule, and for last 3 segments 1, 2, 3. So from this we have to use Simpson's 3/8 rule. So last 4 points means 1, 2, 3, 4, Simpson's 3/8 rule. And for first 3 points, 1, 2, 3, we have to use Simpson's 1/3 rule. And then we have to simplify. So Simpson's 1/3 rule, integral I is equal to, so we are going to have integral 1 and integral 2. So integral 1 can be given by b minus a divided by 6, or that is Simpson's 1/3 rule gives us as b minus a divided by 6 and f of x naught plus 4 times f of x1 plus f of x2. So this is for first 3 points. Then I2 for last 4 points, I2 is equal to Simpson's 3/8 rule can be written as minus b by a divided by 8, b minus a divided by 8 in bracket f of x naught. Now here we have to consider as f of x2. It is starting from f of x2 plus 3 times f of x3 plus 3 times f of x4 plus f of x5, close this bracket. So starting, instead of 0 we are starting at 2, so 0, 1, 2. So this was for first Simpson's 1/3 rule, and we are starting Simpson's 3/8 rule from this. Therefore first term will be x2, x3, x4 and x5, so on. So instead of x0, here we will have x2. So now integral I1 can be obtained. Minus b minus a. B is 0.8. A is b minus a is 0. So but here what we are going to do for first part, here b is 0.32, not 0.8. This is 0.32. This is important. We are treating this as one problem. This we are treating from this as second problem. So for first part, a is equal to 0, b is equal to 0.32 divided by 6. Then f of x0. F of x0 is 0.2 plus 4 times f of x1 is 1.2969190 plus f of x2 is 1.74339328. So if we simplify this I1 value, we get as 0.38023. So if we get simplification of first equation, integral I part 1, for first two segments or 3 points, 1 2 3 points, we get this integral for first two segments. Then integral for second two segments, I2. So b minus a, again b for this is 0.8 and a is 0.32, because we are starting at 0.32. So 0.8 minus 0.32 divided by 8. You can see here starting at 0.32, ending at 0.8. So 0.8 minus 0.32 into f of x2. This value is 1.74339328 plus 3 into f of x3 is 3.18601472 plus 3 into again f of x4. F of x4 is 1.3 into 3.18192896 plus of f of x5 is 0.232. So on simplification, we get this integral as I is equal to 1.2647. So I1 we know, I2 we know. So total integral I is equal to I1 plus I2. That is I1 is equal to, which we obtained here as 0.38032, and I2 we obtained as 1.2647. So total integral we obtained here as 1.645077. Therefore the true error is also going to get reduced. So true error, the true value is 1.64 1.6405334 minus 1.64057 divided by 1.6405334 into 100. So this percentage true error we get as 1.6405334 minus 1.64057 divided by 1.6405334. So error is going to be 0.0026 minus 0.0026%. So this is how the error is going to get reduced. So this error is again still less than the previous errors. So this is how we can use the Simpsons 1/3 rule and 3/8 rule in combination to obtain integral. So now we have to solve certain other problems to simplify some other trigonometric functions. So now let us consider one more problem. Evaluate I is equal to integration from 0 to 1 sin pi x. So exact integral of this is exact value is 2 by pi, or that is 0.6366 1978. So now we want to simplify this using Simpson's 1/3 rule, multiple application of Simpson's 1/3 rule. Multiple application of Simpson's 1/3 rule. Let us divide this into four segments, that is n is equal to 4, whereas h is equal to 0.25. So 1 divided by 4 is 0.25, h is equal to 0.25. So now x naught value is equal to say 0. At that time f of x naught, so if you substitute x is equal to 0, sine 0 is 0. So now x1 is equal to 0.25, so f of x1, so 0.25 into pi, then convert it into radian, and then sine of 0.25, x1 is 0.25, so 0.25 into pi sine sine of this works out to be first of all we have to convert this mode of calculator in degree, radians. Then we have to find sine into 0.25. Okay, so this works out to be 0.707 106. Then x2 is equal to 0.5, then f of x2. This is nothing but in place of x 0.5. 0.5 into pi means pi divided by 2. Sin 90. Sin 90 value becomes 1. So this is 1. Then x3 is 0.75 f of x3. Then 0.75 into pi sine in radian. Then we get this as again 0.707106. Then x4 is equal to 1. Then f of x4, this is going to be 0. Now we write Simpson's 1/3 rule, multiple application of Simpson's 1/3 rule. So now we write equation I is equal to b minus a divided by 3n. In bracket we write this as f of x naught plus 4 times f of x1 plus f of x3. 1 and 3 are odd, so 1 and 3 are odd, plus 2 times f of even terms. Even terms is only x2, so f of x2 plus of f of xn, that is f of x4 last term. So now we can substitute all these data into this. B minus a, b is 1, a is 0, divided by 3 into n. We have divided it into 4 segments. N is equal to 4. In bracket f of x naught is 0 plus 4 times f of x1 is 0.707106 plus f of x3 is again same thing, 0.707106, close this bracket, plus 2 into f of x2 is 1 into 1 plus of f of x4 is 0. So on simplification, this works out as I is equal to 0.63807. So the true error, so here true value is given, that is 0.6366 1978 minus 0.63807 divided by 0.6366 1978 into 100. So this true error works out to be minus 0.229%. So this is how the integral of sine pi x can be simplified using Simpson's 1/3 rule, multiple application of Simpson's 1/3 rule, where we have taken 4 segments. So similarly, for homework purpose, I would like to give some other problems. Integration I is equal to 0 to pi by 2 sin x dx using Simpson's 1/3 rule. N is equal to 4, taking 4 segments. Simplify this, as well as I is equal to integration 0 to pi t sin t dt using again n is equal to 4. Simplify this, as well as integration I is equal to
integration from 3 to 7 x square log to the base e x dx using Simpson's 1/3 rule with 4 segments, or multiple application of Simpson's 1/3 rule. N is equal to 4 segments. 4 segments are 5 parts. To simplify these numericals using Simpson's 1/3 rule, multiple application of Simpson's 1/3 rule. Okay, we stop here.